I want to say hello to everyone and a huge thank you for joining us today on the discussion for ways your teams can realistically improve code quality. We know that realistically is an important word in there. This is a Lead Dev webinar created in partnership with DeepSource, and we actually have Sanket Sarav here from DeepSource on the panel, which is really exciting. The webinar will last 45 minutes, like I mentioned, after which both myself and all the panelists will head over to the LeadDev Slack and we'll answer questions in the technical strategy channel. So if you're not already in there, make sure you're in there so that you can send us all of your questions that we may or may not get to in the session right in the channel, and we'll be there to answer them. We'll probably have some time to answer a couple of questions live. So there is a Q&A feature in Zoom. You can go ahead and start submitting those as the conversation is going on. You can also pile them on if you want. We'll be picking and choosing depending on where the conversation is going, and anything that we don't answer, you can feel free to post in the technical strategy channel at the end. So without further ado, let's get started with some introductions. I'm Maud Lemaire. I work at Slack, which is now owned by Salesforce. I've been there for about 6 years. I lead our load testing operations, and I'll be joined today by a very fabulous set of panelists eager to share all of their experiences and insights. I'll ask each of them to introduce themselves one at a time so that you can get a sense of who they are. So I will start with Usha.
Hey. I'm Usher. I'm a principal software developer at NeuroID. Prior to NeuroID, I was a developer at Salesforce and Usher. I love the challenge of solving software puzzles and working, but my fingers have been burned one too many times with poor quality. So I'm always excited and take immense pleasure in building teams that in which every developer is empowered to build high quality code. So I'm very excited to be part of this panel right now.
That's great. Thanks so much for joining us. And next we'll hear from Joel.
Hi, I'm Joel Chippendale. So I'm a CTO coach and advisor. So I see the impact of code quality on many teams at the moment. I also have 20 years experience of making mistakes in leading teams, mostly at startups and scale-ups. And I'm really keen to talk about code quality because for me, it's really important to see the sustainability of the teams that I work with. And code quality is absolutely essential to the mid to long-term success of a team.
That's great. Cool. All right. And Eleanor.
Hi, I'm Eleanor Seta. I run System Structure Limited, which is a small consultancy where we specialize in fractional chief security officer services for kind of small to medium-sized startups. So I work with a lot of different dev teams, and I care about, my bailiwick is on the security side, but I care about code quality for a bunch of different reasons, partially because things like resilience and reliability are also security properties, and also because code quality tends to directly impact how fast teams can actually shift their ecosystem and their architectures, which is often something, I will come in and be asking teams to okay, well, we need to redesign this thing. And it's like, well, can we? So I have a lot of different reasons to care about it.
Oh, the can we question. Yeah, that's always the hard-hitting one. All right, and finally we have Sanket.
Hi, I'm Sanket. I'm one of the founders of DeepSource. I have been writing code for almost a decade now, and at DeepSource we have been spending a lot of time. DeepSource is a code health platform, so I have been working on this problem for 4 years now. I've had the opportunity to see a lot of our customers on that journey where they started using DeepSource from a small team to large enterprises. I've had the opportunity to view from a very high level how larger teams systemize code quality, how they think about code health. So I'm super excited about the panel and to talk about this.
Great. All right, so let's dive right in. I really like framing conversations from the very beginning by having a really solid understanding of why these things happen, the circumstances by which the problem arises before we actually try to solve it. So to kick things off, I want to explore why and how code degrades. And to start that off, we'll go to Usha.
So I have three main reasons that I think a code degrades. One is when we start developing as developers, right? We, as developers, as managers, and as a company, right? At the end of the day, company makes money when a product is built. So we are always building the product, adding new features, and that's what drives our business. So the quality of code kind of takes a backseat. One of the main reasons is time, the first reason. The second, I feel most of the college grads, right out of college, it's not, code quality is not something that is taught in schools. So that kind of creates a knowledge gap. And also knowing what solid principles are or having that knowledge doesn't necessarily translate into application of that knowledge. How do I apply solid principles to the code base that I have? I don't know. So that also creates a knowledge and application gap there. The next is motivation. It needs, like, the organization, right from the senior management to the developers, everybody needs to be aware that high quality code is important for sustenance. Otherwise, most often features are rewarded. If I do 10 features, I might get a promotion. But if I write 1,000 unit tests or any kinds of tests, or I write well-crafted code, does it get equally rewarded? So motivation is another important factor. So I feel that these are the three main reasons code generally degrades.
Could I add
Joel,
something
yeah,
to that?
absolutely.
So I agree with all of that, Usher. I've seen all of that play out. I think there are a couple of other things that I would add. And the first is that I think code degrades over time. So even if you created great code, really high quality code when you first wrote it, it tends to get worse over time. And that's because the context you're running your code in changes. Your business changes, the direction of your product changes. And so those design decisions that were baked in early might have been great when they were first made, but there's a tendency for them to become less great over time. And also, the larger your code base, the harder you have to work to keep code quality up, just because it gets more complex as you get more elements to it. And so for those two reasons, code tends to degrade in quality unless you're working really hard to address that. So it's not just at the point of creation, but it's that sort of idea that this code is getting worse over time unless you're really focusing on it, I think.
One of the specific failure modes that I've seen is kind of incomplete migrations, where whether it's a service or an abstraction or a whatever, you go through and you do all the high priority cases, often to ship whatever the feature, or even just to, to fix a code quality issue. But, then there's the last somewhere between 10 and 95% of the work. It can be anywhere in there that just doesn't get done. And even if it's a fairly small thing, like even formatting questions, right? Like style questions, that kind of thing, that shouldn't matter. But then, okay, now you have, two different styles in your code, and these things stack up over time, and it starts to become like, it may be, we changed our unit test structure or something, and now half of these unit tests are flaky, or any number of different kinds of things like that, where it becomes, it both lowers code quality, but then it makes it harder to bring up code quality again in the future.
Yeah, of course.
And just to add to Eleanor's point, I think another thing is lack of automation. I mean, if you're starting to put down processes and you've not automated enough, say, for instance, just talking about style, for instance, right? So if, let's say, you're only relying on developers to run tooling, whatever tooling that might be, let's say for JavaScript, you have adopted the Airbnb style, and you're just relying developers to run the formatter locally, and out of like 100 people, if 2 people miss doing that, and that kind of becomes a creep. And then the same way that implementing CI generally ensure that, hey, nobody's gonna commit broken code into the main line, right? I think it's also important to kind of think of automation in any sense, like, even if it is style or anything else. I think as the team grows, I think in my experience, what I've seen is at a certain time when a team grows, there is a certain period of time where you don't have the time to kind of go back and fix things or make things, ensure that things are clean or focus on quality because you're too busy shipping and delivering product. I think at that time, if you take, it's when people miss out on doing this not doing this automation, then 6 months later or 2 years later, they're at a place where it takes a humongous amount of effort to kind of go back and clean it up. So I think that's one of the other reasons why things start to go downhill.
So I want to follow up on that. And like one thing that I hear a lot is the code debt or the technical debt credit card. Like you just like swipe it and then eventually you have to repay that debt.
Yeah.
And obviously like we all go through phases where like we have to aggressively swipe that card, and then eventually we hope that we're given the time to go back and address that debt. But it does sound like the best way to start to address further code degradation, at least, which does seem like it is a spiraling type thing when it is kept out of check, is to institute this automation and keep the gap as short as possible between not having it and having it. But that takes time and energy to implement, right? And it takes time and energy to implement those cultural norms too. How do you encourage leadership to say like, oh, it is worth us, say, shipping this feature 2 months later and doing this now, rather than the opposite?
Yeah, that's a great point. And you don't actually have to do everything all at once, and you can actually break it down into very low-hanging fruits. Like, just think about it in this way. Let's say you never put down any linting, and now you have like 2 different style guides, or you adopted something new, and there are a few different things happening. Now, instead of halting things and saying that, hey, okay, we're going to need like 3 sprints to fix this and fix this entire mainline, at least you can start with picking one thing. Like, you can just say that, hey, okay, everyone uses Prettier for JavaScript. Let's not do anything else except let's just add Prettier into our CI build, right? So at least that will start doing some things, right? And then once you start doing that, at least you're not, even if you don't go and fix the things that are already messed up, like you have a huge technical debt, and not just in terms of style, but in general, if you have like a huge debt that you have to pay back someday, you can at least make sure that, hey, you don't pile up anything new, even if you're not paying off things right away. And we see this very often, especially when large teams who have never used any quality tooling, for instance, they adopt something new and they see that, hey, there's a huge backlog, which they should, it appears that they have to get through that in order to move forward. I think the best way to work around that is to figure out how you can build some tools. If you can't do everything all at once, if you can't clean up your past sins, at least stop, introducing new stuff, and then slowly kind of chip away into your mountain of debt that you have to pay off. So I think it's important for the leadership to kind of engineering leadership to kind of realize that, hey, first you have to have the buy-in that this is important for their business. And I think any sane engineering leader would accept it, even if they don't want to prioritize it. But I think the sensible way would be for them to kind of say that, hey, okay, let's not do 100 things, let's at least start doing one and go from there.
Usha, and then we'll go to Joel.
I agree with everything that Sanket has said. One thing that I would like to mention is also, again, reiterate, I think, is that pushing a project by 2 months might be hard because bread and butter for any company is the products that we deliver. But at the same time, pushing by a week is a better buy-in. So incrementally chipping away and having a baseline for quality again, like doing at least the automation and making sure that with every pull request that we create, we care about quality incrementally. It doesn't all have to be at one go, right? The other thing I want to mention is there should be continuous learning in this. It shouldn't be all or nothing. Our products are never going to be perfect. I think we should focus on progress, not perfection. So as long as we incrementally keep bettering ourselves, I think the code at least will stay healthy, maybe not perfect.
Yeah, I think you both talked about incremental improvements, and I think that's absolutely key. You know, where I've seen this go furthest wrong and trust really being lost in the development teams, where they've gone for a really big change, which is going to deliver, and then they never get to finish it. It takes much longer. Originally it was 2 months, then it's 4, then it's 6, and it's 90% done, and then it falls apart. I was going to say, I think the other thing about getting people on board with improving code quality is really selling those benefits. I think as Alan Holub says, that one of the most destructive myths in software is that it costs more or takes longer to develop higher quality code. And I think this speaks to what you were saying, Usher, earlier around, remembering that it's not just the development of the feature, it's all that maintenance, all the work you do behind that. And that longer term work often outweighs the original cost of the feature. And that's the reason we as engineers want to work on code quality. We want to make it easier to make changes in future. And so being able to tell that story to leadership, we want to go faster. We want to deliver more for you, rather than making it sound like, oh, we want to make it nicer for engineers, is a much better sell, showing that we're aligned with those company goals. And then those incremental changes, talking about the impact that it had, not just doing the work, but telling them the story of how that made things better for them as well as for engineers.
And last point, I think a few of these things are very easy to demonstrate. Like if your biggest problem is having the buy-in from the leadership that, hey, we should spend some time, like what Usha mentioned, like even a week, like getting buy-in from leadership, if that's the concern, that you can show a lot of evidence, like, hey, if you put in some tooling, you can actually see the pull requests not getting blocked as often as they were getting blocked before, right? Or say, again, the same thing as CI, like once you have CI, you see that you're not pushing broken code, and that's very easy to demonstrate. So I think in terms of code quality, if you are struggling to get buy-in from the leadership that, hey, okay, why should we spend like 2 sprints into implementing like code coverage? Like we never track code coverage, and then we are wondering that, hey, why is our app breaking? We can, it's very easy to demonstrate some of these things, saying that, hey, hold on, give me 1 week. After a week, I can show you that, hey, we have increased the code coverage by say 10%. We have recognized this is the most high churn code, or the most critical path in my application. We have made all the tests robust. We have made all the tests in a way that we have covered all the edge cases. And then, hey, 1 month later, you see that this error which used to pop up no longer pops up. So I think finding those low-hanging fruits, and kind of, if buy-in is a problem, then you can find that evidence very easily and show it to the leadership.
Eleanor, it looks like you might have had something to add.
Yeah, one of the things that I've found just as like at the project management level that's often really useful is just have a punch list of like, okay, these are our open set of items. And every time somebody touches a service, like if product comes over and says, okay, we need a new feature in this service, it's like, well, okay, you need to check off 1 item on the punch list, and that needs to get bundled in. And that often, because a lot of the one of the things which I've seen as a stumbling block is just literally, how do we schedule this work? How do we streamline it in? And like, does this come off on like kind of team's own 20% internal improvement time, or like, how does this work out in the shuffle there? And so I found that ends up being a model, assuming your punch list items are relatively predictable, that can end up being a model that actually works for everybody once they're already bought in, of course.
I love that.
Yeah, that's a, that's a,
Yeah,
and
that's a great idea.
how do you, I mean, maybe the answer is just Jira and a bunch of people use Jira, but like, how do you, because I assume, especially in a large organization, like it's implementing the norm that this is a thing and this is how everyone does it. Or, I mean, maybe that's just, you implement that on a team by team basis. And if you are the service owner and you're being asked to do this, then you're like, well, the contract is, if you ask us as service owners to do this thing, here's our punch list.
Yeah.
Is it similar
on the,
incrementally?
Yeah, it depends on the team and the structure. Often because I'm coming in from the security side, if that's a security-oriented punch list, then it'll be a push from us. But if you've got, like if you're a small enough org that you're kind of still one dev org and you've got kind of cross-cutting practices, et cetera, across, across different service teams, et cetera, you can often kind of run that stuff sort of at the like development practice level. And then often one of the things I've seen, if you've got like one of the kind of like service catalogs where it's like, oh, these are all of our services. This is, quality information, reliability information, test coverage, all of this kind of stuff. You can often add that punch list in there as like all the things that we've agreed as best practices. This service complies with 8 out of 29 or whatever it is, kind of thing. So that can often be an avenue forward.
I really like that. I think that's really clever. Yes, Usha.
So I love Eleanor's idea mainly because I usually don't like bundling clean code with the feature development because I usually worry because it becomes a bigger change, which is harder to handle. But if it's just one item on the punch list and we're making sure that it's covered by tests and we're making sure that the existing code is safe, then I think it's a very great idea.
Yeah, and it doesn't have to actually be part of the same change set exactly. If you're in a more CI environment, it can be like, oh, we have the formatting build, the formatting change, and then we've got the actual feature change.
Yeah.
So you could unbundle them, of course.
And another way to kind of implement it, say, and there's something that we did as well. And again, in our team, a relatively smaller team right now, but still what we did was one of the services did not have a lot of coverage, like unit test coverage. So what we did essentially later on was, hey, now we realized that, hey, we need to increase the code coverage. So one simple rule, what we did was, if you are touching a file in a pull request, and if you see that, this file has like, if it's like completely not untested, but if you have gaps, then just add unit tests for this as well. Now, it kind of bloats some bit of scope, like, it's like increasing the scope of the pull request a little bit more, but that's a very easy way for people, for you to kind of, get people to increase something like code coverage if you don't have code coverage at all. And I think we implemented it and, we kind of saw massive success with this. Like, I'm not talking about like huge code bases, but based on these lines, then you can implement this punch list. But I love the idea of having like a punch list for service owners. Yeah.
To follow up on your unit test point, Sanket, and I think to sort of wrap in some of the questions that I'm seeing in Q&A about very concrete KPIs or metrics that we can use as a team to agree on, to agree that the quality is measurable and not just a cultural behavior. So one of the things that I've seen with instituting policies around code coverage is that sometimes programmers being programmers will just write unit tests that like add code coverage, but like just add code coverage essentially and aren't really meaningful just to hit that goal. I think there's a whole, we could go on and on about the psychology of setting goals that are respected for their nature, right? There's like the letter of the law and there's the spirit of the law. I think that also applies here with finding the right metrics that are meaningful for your team or your engineering organization as a whole that really do measure quality and not arbitrary behavior that leads to quality. I'd love to get you all's thoughts on that?
So I believe that empowerment is a big part of this. People shouldn't be doing something because it's the law or they're supposed to do it. Culture building and empowerment are the big keys there, right? People should buy into the idea and they should feel empowered. So having discussions around why are we doing this is a very important thing. When and let's say if one of the rules is formatting is important, right? But maybe for your code base, I mean, it's not true, it's just a random example, but then let's say for your organization, formatting is not a big deal at all, right? So in that case, you can have a healthy discussion around it and say, hey, let's skip this rule. Maybe it makes sense for the entire industry, but not for us. Let's just skip this one. And empowering the team to make that decision into, yes, this works for us, this doesn't, let's not follow this, becomes crucial in them recognizing that they have the power to change things that don't work, but at the same time put that work into quality that they think is important.
Joel, I think you also had something.
Yeah,
to
I would.
follow on.
I mean, I'm a similar point to Usher actually. I think it's very much about. So I would see this as, you know, we're improving code quality to make it easier to make changes in future, and I think it's, you know, it's worth spending a little bit of time with the team thinking about what it is that's holding the team back from making those changes more rapidly, and that will help you think about what you're going to focus your time and effort on. Like Sanket was saying, you know, let's pick off the low-hanging fruit. Let's do the easy things that make things better for people and build up that trust. But it also helps directors in thinking about what are the measures that are useful right now. Perhaps it's taking forever to get pull requests reviewed, and that's really slowing the team down. And so you're going to make some changes around processes there to improve that. Well, then have some measures around the pace which it takes to get code reviews done and things merged into your main branch. And that can be a measure that's useful during the period of that project where you're improving that. When you've got it to a certain level, maybe it's much less interesting to measure, it's more of a hygiene factor. And I think those ongoing conversations between engineers about what constitutes good code quality for the context you're working in are really valuable. They're great opportunities for engineers to learn from one another and build on their ideas around code quality and build their skills there, as well as helping improve the quality of the code. So yeah, double down on what Usher was saying, really.
Yeah. And just adding to that, I think I love the last point. I think the context is the key word here. Say, depending on which team you are on and what kind of products that you're building and what's the current thing that you're focusing on, it shifts. You know, your focus shifts and your definition of what quality means, that also shifts. So, for instance, like a 5-developer startup, they might not really care about code coverage because, you know, they're too busy kind of trying to ship things out, get to product market fit, and then they can raise more money and then scale the team and blah, blah, blah. But once you hit, like, say, 20 developers, which means by extension, you probably would have seen some success. And now you have to do things from a larger scale. Once you have hit 50 developers, now you need to think about, hey, onboarding time for my new developers, right? Like that's something that you never had to think about in the past. So I think at every stage of an engineering org, you need to have this conversation about explicitly defining what your code's health means to you. So for a 4-people startup, the code health probably doesn't mean anything except maybe some comments. But that doesn't mean, but that's completely different for someone when the team is growing. So I think at every point of time, you need to have this, you need to enable everyone to have this conversation that, hey, let's explicitly define this is what code health means for us. Have a few graphs, like define 1 or 2 metrics. Like that is super important, because if you're not measuring something, then you're just, you're not, anyone, if you don't bring data, then, it doesn't mean anything, right? So if code coverage is something that you care about, you need to put that on a dashboard and, you need to look at it. But I think that's a rolling target. But it's super important to have that conversation. And then And then finally, some of these things, say, for instance, like low-hanging fruits, right? Say, if security is your focus, let's say you're going through compliance and, security, source code security is your focus, then for that, let's say that for that quarter, you can focus on, hey, this project, let's get rid of all OWASP top 10 vulnerabilities. And that can be like smaller targets that are easier to achieve than, having code health or code quality as a very abstract concept. So I think that is something that, we have seen a lot of successful teams. And one of the articles that I've been pouring on was Google's testing blog, where they described that, hey, they created a code health group inside Google that only works on this. And one of the key things that they talk about is how they defined some of these metrics explicitly and work towards it. And that's like a rolling thing that you have to define for your org, at a certain period. So I think that's something to add to what Joel said.
I want to
Eleanor,
add
did
something.
you? I just want to give Eleanor a chance to say anything on this topic before we keep going, just in case.
I guess just a brief comment. And I know we're mostly talking about achieving code quality rather than what is code quality. But I would say, kind of to Sanket's point about security and code quality, I would say often from my perspective, a lot of it is more about kind of defensive coding style than individual vulnerabilities. I know, like, I work with companies at all points in their security journeys, and sometimes, it is okay, we have endemic SQL injectability, we need to just go through and deal with that. But a lot of the time, I would say for organizations that are successful at application security, it does pretty quickly get to be not about, individual vulnerabilities we deal with on a kind of a more, a faster basis. But it is more about, are we writing this code defensively for the vulnerabilities we don't know about? And that becomes often much more, again, of a stylistic and architectural question.
Yeah, abstracting those problems out, I think, is very much a theme. So I want to go back to the Google Code Health team, because it is a way that I think it's a pitfall that I think a lot of companies, once they get to a certain size, maybe fall into, where they sort of assign code health and architectural health and in many cases, like, security teams at large companies also fall into this trap of it is your job to make sure that everyone is doing this thing. And it can feel, some people really love that role and really thrive in it, but over time it can feel a little bit draining to be sort of almost always the person with the stick of, like, well, your team didn't meet their code quality goals this quarter, and so, like, I'm going to come for you, and whatever that means in whatever context. I've personally, like, worked on the refactoring team before, which was great when we had a lot of steam in our engine, and then, like, not so great about, like, a year in when we all were kind of, like, losing that steam. And so I'd love to get all of your perspectives on if that is a sustainable way to do things, implement things, maybe at a bigger scale, because usually this happens in slightly bigger companies, or how to keep that momentum. Any thoughts you have on that? And I guess, Eleanor, I'll let you go first on this one.
I mean, that kind of baking it into the PM lifecycle that I've found has been one of the things which I've seen actually work, because then it just becomes automatic. I think to a certain extent, kind of what Usher was talking about in the beginning is it depends on the incentive structure that management provides for the teams. And I've seen this in a bunch of different contexts where if as a sort of a secondary concern, I guess, from my position often, if management provides incentives around security, it happens. If they don't, it doesn't. And regardless of kind of what the work is, because it's almost always, in someone else's work stream that I need to see stuff happen. And I think that's, so how you incentivize stuff does really drive a lot of this stuff. One of the things which I've found is actually really important is limiting total feature velocity. And this is something that I'm encouraging kind of engineering leaders at all of my clients to have some understanding of, what's your max feature velocity for your team, and then how far can you afford to back off of that? And because this affects stuff like code quality, it affects, code security, but it also affects stuff like, I don't know, it's 4:30 on a Friday and something just fell over, right? Who's going to take off early and who's going to stay around to fix it, right? Because if everybody's been pushed flat out and nobody's had a vacation for 2 months, it's going to be a real empty office, and there's probably going to be 2 people there who are like, okay, fine, if nobody else will do this, I will. And then how long are they in the company for? So that's one of the things that I've found for a lot of this kind of stuff, biting off less and doing a better job ends up, yes, it delivers better quality, but it also ends up delivering faster results in the end because people can just do the smart work. So I found that makes a huge difference.
Yeah, and I think not. I mean, Google is at a different scale, so I think you literally don't need to create a code health group. I think the point is of that group, and if you go and read Google testing blog, and that's where the code health group, they write about what they're doing. I think the primary thing that they talk about is it's important for an organization, especially the engineering leaders, to be cognizant of code health as something that they have to measure. And then just start with, you don't even have to have like someone dedicatedly working on it, but someone should be responsible for it. And that's if the engineering leaders, let's say the VP of engineering is someone who's like, hey, okay, this is something of a priority, then you can do that on a, I don't know, temporary basis, like, hey, this quarter, let's do something for automation. And, and a lot of these things are, you put it once and you're not gonna, you don't need to look at it again, like, hey, code coverage, you put it once and then there's a dashboard that shows you, hey, what is the, adopt tool, what is the code coverage for each PR, and go set up those blocking rules on GitHub and GitLab or Bitbucket saying that, hey, if there are, the same way that you say that, hey, if there's a faulty build, you cannot merge it. The same way you say that, hey, if you're reducing the code coverage, you do not merge it. Or if someone is breaking like prettier config, the prettier build or whatever, the Airbnb style, you cannot merge it. So it's I think you have to take the decision making out of a lot of these things, and the only way to do that is using automation and having like setting aside a metric that everyone agrees upon, that hey, even if you're not improving this metric, at least we should not degrade this metric. It's as simple as that. And then as you go larger and you can afford like thousands of engineers, you can go and build a team and innovate on stuff.
Joel, you were taking notes.
So almost all the teams I've worked with are less than 100 engineers, and I think it's all about how you build those incentives into the teams and how you educate and how you show what you value. And I think to Usher's point earlier on, people get rewarded, and be that implicitly by people clapping and whatever it is around the new feature for the new client. And I think it's up to engineering leadership to really bang the drum of the value of the other things. And you can show that value in so many different ways. And people will notice what you talk about and what you appear to value. And so you can drive a lot of that behavior, I think, in a smaller team like that. I'm nervous about breaking things out into, when you said the refactoring team, part of me died inside. Like, I don't know exactly, you know the work that you did, etc. But I think for, maybe for individual projects of refactoring, I think it's useful to bring a team together rather than try and distribute it across everyone. But I think in the long term, everyone needs to be responsible for that. You need to find ways to build it into the teams, perhaps with the, what was it called? The punch list from Eleanor, or, or as Usher said, every commit should be better than the last. You're improving code quality every commit. How can we all work to that?
Yeah, some of the context for that was it was more of a tiger team type situation that we put together, but it did turn into one of those things that it took way longer than we thought it would.
Yeah.
And yeah, we had to find ways to like keep momentum going because we had made some commitments and we didn't want to be what Eleanor mentioned at the beginning, to like did the bulk of it or even just the 5% of it and left like 95% undone. We wanted to make sure that we weren't going to create a new problem by only like half getting there, which is really tough sometimes.
Yeah, and I think it's really important with those as far as possible to create, intermediate points that are improvements in code quality rather than all being worse until you're finished. And that's hard, it's definitely in the general case, that's very hard. But yeah.
And actually, I think that ties into a good sort of final question for us to talk about here, and then we can move to the channel about like short-term versus long-term maintainability. So we all talked about iteration and starting with the like really low-hanging fruit and taking that approach and building off of that and building that momentum. But when there are sort of these like really pernicious problems that we've noticed, like Eleanor, I think you mentioned like this architecture just doesn't work anymore and we need to like completely move to something else. Do you take, ideally, right, you're going to take this iterative approach to moving off of that architecture onto something else. But is there anything you would do differently that, because you're building towards this very specific goal rather than like the sort of overall broad goal of code quality, is there anything you would do differently organizationally with your teams in that context?
I mean, I think it's difficult for me to come up with a general answer for that because it's always so fair. Specific to the structure of the team. I mean, I think in some ways it's the same as any spike or any sprint of a similar scale. I think that again, for the finishing it part, a lot of that comes down to incentivization, right? And it comes down to incentivization, I guess, also to a certain extent, communication with your outside stakeholders, because often there will be the kind of, okay, you get the bulk of it done, and now product is breathing down somebody's neck. And do you have engineering leadership who's willing to push back and say, no, this thing isn't finished. No, we can't do your quick and dirty hack this weekend. We really need to hold the line on this. So I think a lot of the stuff I see is mostly at that level. And then below that, it depends on the specific problem.
That makes a lot of sense, yeah.
So short-term versus long-term mostly depends on how big your code base is, right? To Sanket's point before, when you start off small, you're a small company, then you can easily take short-term goals and then achieve them. But then if you're coming from a large organization and this is the first time you're looking at something like, let me try to introduce these metrics, you would have to go for a long-term goal where you, let's say in Google's case, right? We've been talking about it. Google started it with their software blog was called Testing on the Toilet, right? It was not something which was forced upon people, but they made it fun. But then it was omnipresent. They had this is how we do it sheets all over the toilets, and it worked out well for them to make it fun, but at the same time have some automation around it to, again, Sanket's and Eleanor point, where we make continuous improvements again. So to answer short-term versus long-term, it's subjective, like Eleanor said, but it also means how big your code base is and how much you want to give the product team a pushback on the deliverables.
Yeah, and just to add to that, I think when you think about short term versus long term, a lot of the initiatives that you can do, they are going to have the same kind of impact on your short term goals versus long term goals. Like, say, for instance, any kind of automation. And again, if you talk about the size of the code base, that could be different. Like, I'm not talking about like a complex code base, which is like a monorepo with so many different technologies. But in most cases, for most people, adding some automation, right? If you don't have an automation, even if your short-term goal is to, hey, okay, things have been burning for the past like 2 months and we need better stability, versus, hey, how do we sustainably build on top of a solid foundation so that, we can onboard engineers? Both of these goals can be solved by a simple solution, which probably won't take you more than a week to implement, right? Or say a single contract between every developer saying that, hey, all of us agree that we will have peer code reviews, right? A simple contract. So I think, a lot of the things do not, like, the effort does not matter if it is going to be short-term or long-term. I think it's important for us to, I think I made this point already, but it's important for us to kind of take a step back and see, hey, what are the low-hanging fruits? Some of these things can be implemented today, which are going to pay off in the long term. So I think that's one nuance there.
All right, so we're about 1 minute over. Final thumbs up, thumbs down question, and we can take that discussion into the technical. Oh my gosh, what was the name of the channel? Technical strategy channel. Yes. Okay. So thumbs up, thumbs down, and we can take conversation to the channel, and I'll close things up. Code Health Days. Interesting. All right, we'll take that to the channel. So thank you everyone for all of your wonderful insights in today's panel. We're gonna head to the channel, so please follow us there. And thank you for joining, and we'll see you around at hopefully another one of these at some point. Bye everyone.
Thank you.
Bye.
See you in the channel.
Bye, everyone.